In a dim London laboratory, a young scientist spent long nights studying fragile strands of a mysterious substance, letting X-rays pass through them and reading the shadows they left behind. Where others rushed to theorize, she measured, carefully calculating the spacing, the symmetry, the quiet rhythm hidden within the blur. From one haunting image, she saw the unmistakable signature of a helix, the very architecture of inheritance. Others would use her data, publish first, and be celebrated as the discoverers of life's double spiral. She would move on to map the structures of viruses with the same fierce precision, her health fading long before recognition arrived. The woman who first truly saw the shape of a genetic destiny was Rosalind Franklin. The image she captured changed biology forever, but today her story changes us. As we celebrate National Science Day 2026 and its theme, Women in Science, Catalysing Viksit Bharat, we remember Rosalind Franklin, not as a footnote in history, but as a force of transformation.
As Dr. Asima Chatterjee, one of India's pioneering women scientists, reminded us, a nation's true progress rests upon the advancement of science and technology, and decades earlier, Marie Curie reflected that the most beautiful experience in science is the sense of mystery, the emotion that gives birth to discovery. Science is both responsibility in wonder, it is both national progress and personal curiosity, it is both discipline and imagination. Good afternoon, one and all present here. Respected Honorable Vice Chancellor, esteemed dignitaries on the dais, distinguished faculty members, dear research scholars, students, and the guests, it is with immense pride and privilege that we welcome you all to the mega event of first of its kind Science Day celebrations 2026 at Pondicherry University, which is even more special this year as we mark 40 years of excellence, 4 decades of academic brilliance, research, innovation, and unwavering commitment to knowledge. Let us now commence this auspicious occasion.
It is now our honor to invite Professor Joseph Selvin Sir, Dean, School of Life Sciences, to deliver the welcome address and formally greet the gathering. Selvin Sir, the podium is yours.
So I am delighted to welcome all the stakeholders of the university, as well as the teachers and school students assembled here. So this is the remarkable milestone of Pondicherry University. We cannot forget this day. So I extend first the warm welcome to our Honorable Vice Chancellor, very esteemed and Honorable Vice Chancellor of Pondicherry University, Professor Prakash Babu. Professor is not only an academic administrator, known as a well-known neurobiology scientist in the world, and then a professor of eminence, and a lot of administrative positions in the University of Hyderabad, now leading us in a transformative way. Past 11 months, the university is transforming in a global scale. This is the witness. We can say 40 years of excellence. The university stands for 40 years. Now this day is, we can recollect, the entire university exists. We may not be here, but everybody will say, this is the beginning of a National Science Day celebration, how to make it. You can imagine, this is like, I cannot say, I personally feel like a competition. You can see school kids are making exhibitions and innovations one side, and our university faculty, our students, our research scholars making lot of exhibitions. So that makes everybody together. So this is the first time, maybe probably the premier institutions like Indian Institute of Science, IITs are allowing the school children, public to the open day. So we made it to the beginning. This is only because of Professor Honorable Vice Chancellor, Professor Prakash Babu. So, we all inductive. This celebration not only benefited the entire stakeholders of the university, as well as all the students and the like school students, parents, and community in Pondicherry by and large. I extend a warm welcome to you, sir. I sincerely appreciate and welcome Professor Rukmani, behind the scene, probably, Director of Research, who has served as the overall coordinator, and all the events under her guidance, meticulous plan, we made it very successful. I extend hearty welcome to Professor Sivakumar, who will be inspiring with a talk, who is a IIT Madras alumni, and he is known for his field of expertise. And I'm not well versed with the physics, but still, I welcome you, sir. I welcome Professor Alok Sharan. So, a renowned professor of Pondicherry University with us, and he will usually, this day usually celebrated with physics. Now we expanded through entire university. So I welcome Professor Alok Sharan. Dear students, you will see the front rows are occupied by many of the experts. Each one a scientist. You might have studied historical scientists in the books, but you may not studied them. Today you have seen a lot of exhibitions, lot of things in the open day because of their research contribution. I welcome all the faculty, all the deans, HODs, as well as the research colleagues of Pondicherry University. I welcome all the school students, teachers, their parents to this important occasion. You will be receiving prizes. Those who are not receiving prizes also, I appreciate you. Your effort will be award-winning in the future. I welcome you all. Thank you.
We shall now proceed with the felicitation ceremony. It is a moment of great honor for us to recognize and express our gratitude to our esteemed professors and dignitaries for their invaluable contributions to academia and research.
It is a privilege to invite our Honorable Vice Chancellor, Professor Prakash Babu sir, whose visionary leadership continues to elevate Pondicherry University to greater academic heights, which we can all witness from the vibrant activities upheld at our university. Sir, may we request you to kindly address the gathering.
Very good afternoon, all of you. It's my pleasure to be here on this occasion. The guests on the dais, Professor Selvin, Dean School of Life Sciences, and Professor Alok Sharan, Dr. Shivakumar, Professor Rukmani, Dr. Sangeeta, and other organizing team here. So many people are here, right? And also the heads of the departments and other faculty members, invited guests, teachers from various schools, students, media and PRO office. Really I'm happy to be here on this day as I witness a lot of vibrant activities in the university for the last 2 days, today, and it continues to tomorrow also, right? Yeah. So it's really a National Science Week we are celebrating it. As you know that the Science Day is to inspire the young minds. As the students, not sure that how many of you know that the Science Day is being celebrated every year on February 28th to mark the great discovery of Sir C.V. Raman. It's called Raman effect. He is the first Nobel Prize winner for India in sciences. And that we are marking to ignite the young minds to say that the science is the one which takes the human lives for the better and comfortable living. Science Day, science is it's a way of thinking. Students should keep thinking about the science because science transforms the curiosity into discovery and dreams into reality. So students should have the dreams. It's every children or every child is a scientist. People may wonder that when they become scientists, right? Every student or every child, in fact, every child is a scientist because only mother knows that. The way they ask the questions at the end of the day until they fell in sleep, it's very difficult for the mother to answer them. Very curious questions they ask. So any scientist starts from the questioning. When you stop questioning, you are not doing anything or your thinking capacity is lost. Children, you should start questioning. Never stop questioning because a good example everybody will quote. I will also remind you about the Isaac Newton discovery. When he was sitting under the apple tree, apple fell on him and he did not throw away and he left the place. He started thinking why the apple fell down, why it did not go up. Simple. He keeps thinking, then that led to the discovery of the gravitational force of the earth. So that's how you should start questioning. These students, you should start questioning, question the teacher. Whether the question is good question or bad question, there's no good question or bad question. Question is a question. And all the teachers here, gathered here, it is our responsibility to respond to them and convince them with a utmost care because these are the scientists of tomorrow. I will give you a small example. I think I must have quoted somewhere. When a child was at home, one guest came. He asked about the child, which class you are studying. He said, Uncle, I am studying 5th class. Then he asked a simple question. What is the shape of the earth? What is the shape of the earth? I think most of you must be knowing, right? What is the shape of the earth, students? Yeah. So, he said a beautiful answer, but he got actually shocked for answer. He said, Uncle, earth is round at the school, but flat at the home. So, he is right or wrong? He is absolutely right. So teachers, they keep telling that earth is round, it's like globe. He started globe. It's only in the class. But when he comes and observes at the home, earth is flat only. So where it is lacking? So the teachers should convince them they cannot see as a flat surface. Globe is globe because he has to travel a miles away in the space, then only he can see the space of it or shape of the earth. So the questions, ultimately what I want to tell you is the questions are genuine. and questions, it is our responsibility to answer them. So the earlier the students, they also spelled about the importance of the Science Day this year. It's a Women's Science Day, and also they also mentioned about the few names of Indian successful women scientists. And science doesn't recognize the sex. It doesn't have. All are equal. Now these women scientists are in the Space Research Center, and woman is leading the Space Research Center as of now. And Indian science, you can see we have attempted the Mars orbit mission, and Indian science achieved the global excellence with the low cost. That is the important thing. Great science does not require any expensive laboratories, but it requires only great ideas. And another milestone for India is the Chandrayaan-3, where the first country to land near the moon's south pole. India is the first country to land on the south pole of the moon. So it requires the hard work, teamwork, and the scientific vision. So today's students can become tomorrow's, some of you may become a space scientist tomorrow. And the important personality in the country whom we can take as an example is Dr. APJ Abdul Kalam. He is called as the missile man of India. He rose from the very humble background, and he became a great scientist, visionary, and ultimately President of India. He inspired the millions of children. He always, during presidentship, he always prefers to go to the colleges, universities, and schools to deliver. And also once he said he wanted to die while he is in his duties. He is performing his duties actually to spread the science. So likewise, in one of the northeastern states, when he went for delivering a talk, on the dais itself he was collapsed. So that was the commitment of the Dr. APJ Abdul Kalam. And he inspired the millions, and the dream is not that which you see while sleeping. People say that I got a dream because while I'm sleeping only. But something that does not let you to sleep. You should have a dream that you should not sleep until you achieve our goal. So that is the dream that everybody should have that. Big dreams always led to the biggest achievements. Other important personalities we can take, Dr. M.S. Swaminathan. He is the father of Indian Green Revolution. After the independent India, India has been suffering for the lack of adequate food to supply for the people. And many people, they died of the poverty. Many people died of the hunger. But this man, Dr. M.S. Swaminathan, is the one who made the self-sufficiency to the India where people can really survive. And science can solve the real problems. So this is the real problem of the country after the independence, and scientific achievements, it only changed the India and shaped the India. And also, the students, I think you can have the bigger landscape. You can become a scientist, engineers, doctors, innovators, and also the entrepreneurs. So the scientific advancement will transform. And also try to learn things beyond the textbooks. Even teachers also, you should teach them beyond the textbooks. Then only students will get the inspired. When you are teaching, some people say that the students are not good, they are not listening. They are not paying interest. They are not very serious. Either interest, seriousness, and interest of the students depends upon solely on the teacher. How you teach. Imagine some teacher's class is full, some teacher's class is not full. What is the same student? So that means the way you teach, the way you attract the students and children is very essential. So that you can transform the lives of the students, generations of the students and also the country. So therefore, I strongly advise the students will have the curiosity, hard work, and persistence that leads to the scientific success. So science is the engine of the national development. One can become a great C.V. Raman, Dr. Abdul Kalam, or any other great scientists in the country. So the future belongs to those who question, explore, and discover. Let us celebrate the National Day by promising to think scientifically and work for a better India. With these few words, I congratulate the organizers. When we proposed that let us have the Science Day, all the faculty members have come forward, and interestingly, some of the faculty members, they have gone little beyond their scope and also attracted the students, some of the models, and the students that they made the models were amazing. All our MSc students, graduate students, today I have seen everybody, in fact, most of them, I could not cover some departments, I think, but they have largely done wonderful job. And also the school students also, they made a beautiful models. Even I cannot think of during my student days. So what amazing models that they have done using the technology, using just mobile phone. Using mobile phone, they have done a lot of things. So that means you have the greater responsibility now to ignite the young minds so that definitely they will become a great scientist in near future. And all these two children, so Pondicherry University, since you have seen the university, departments, laboratories, instruments, and what are all the things. So I want you people to take the science as the career and come to the Pondicherry University for your graduation and also post-graduation studies and also for PhD. I wish you all best of luck, and once again thank and congratulate the organizers for a wonderful job all of you have done. Thank you.
Thank you so much, sir, for your extremely insightful address. Science is a journey across time built on ideas that challenged convention and redefined reality. To enlighten us on the historical development of quantum physics, we invite Professor Shivakumar to deliver the special address. Sir, we are eagerly awaiting your insights.
I thank the Pondicherry University administrating, starting for our respected and honorable Vice Chancellor, Deans of the schools, heads of the department, and faculty members who have made this event a successful one. And I also thank the administration for giving me this opportunity to make a appealing presentation to the school children especially. So my objective today is that to give this some introduction or historical introduction. Main purpose is that to generate some motivation and interest to the school children, because the target audience is going to be school children, typically from 6th standard to 12th standard. There may be some college students may be present, but if the audience is ranging from 6th to 12th, we are also going to miss out some important students, namely those who are studying 10th and 12th, because board exam is going on. So that is really a missing part. One point that I would like to mention before starting the introduction is that children have this opinion, namely that when we tell some information that this is the fact, then the child replies, this is not there in my textbook. This is the reply. So they are not ready to first listen what I am saying, but instead the directly reply comes, this is not there in textbook. No, it will come in next year. When I say, then I will see that next year. So this is the information. That means students want to wait until the material is available in that textbook. So before that you can't tell them. This is what I have observed based on the interaction with these students. How it is going to impact what I am going to speak today is that when I am going to show so many things on the slide, how much of that will be there in their textbook is a question mark. And that too, variety of students of different classes. So even our Vice Chancellor have mentioned it clearly that teachers will be training the students in such a way to go away from the textbook. You need not have to stick to this textbook so much stringently. You must be in a position to look that side and this side little bit. So that kind of tradition is still not there. A kind of very rigid atmosphere is still there, I understand. And in a way, coming out of the school and attending this kind of events is also a very great enthusiasm for the school children, that they are always tightly fixed in some kind of mechanical work. Namely, they do the homework, they write the assignment, then they lift maximum possible load that a child can lift and then go to the school. They take huge amount of books and notes. I don't know why they want to lift that much book and note still. So ultimately, the way the students, when they come outside and then learn, that will be little bit more comfortable. You feel more comfortable to learn rather than a burden. So this is what I think, that this event is going to facilitate like that. If the event is spread over much more number of days, it will be very nice. But it is going to be there today and tomorrow, 1 or 2 days. So here, to start with this introduction, I'm going to see like this. The first slide is going to be like this. Usually when we go to the school, we always learn 1, 2, 3, 4. Okay. So now the sizes or the dimensions are going so big and so small that counting like 1, 2, 3, 4 is not a good idea. So you count 1, 10, 100, 1000 like this. So that you can see the screen there. Don't count 1, 2, 3, 4. You count 10 to the power 1, 10 to the power 2, 10 to the power 3. Like that you count, so that you can reach big numbers, and similarly you can also reach very small numbers by doing 10 to the power minus 1, 10 to the power minus 2. So the counting should be like this rather than 1, 2, 3, 4. This is one thing that you children have to grasp, the point to be noted here. And then this kind of counting is what we keep the order of magnitude. Because order of magnitude is something which we frequently use. Order of magnitude means what is the number above the 10. Okay, 10 to the power 5 means 5 is the order. 10 to the power 7 means 7 is the order. So here I have written some numbers. 1 lakh is written. I am saying that 1 lakh is 4 orders of magnitude larger compared to 10. Right? So you are going to compare two numbers. Which one is going to be bigger? Okay, we don't say it is 1 million times bigger, 1 crore times bigger. That language is not going to be useful. So we need some method to deal with very, very large number and very, very small number. Okay, when you are talking about 1 million, it's okay, 10 million, okay, 100 million, okay. Then what happened to 1 million crore? 1 million crore, how will you write and how will you speak? It's totally confusing. So this method has to be avoided. We need a nice method, and that method is the order of magnitude. Find out the number that is sitting above 10. Okay, 10 to the power 5 means 1 lakh. So lakh and all you forget. You have to remember 5 is sitting on top of 10. So that is the first slide that I have. And then when we go to the second slide, here I am showing two numbers. One number is so big, another number is so small. Forget about that 6.6 etc. You have 10 to the power number. 10 power, one number is 10 to the power minus 34. The other number is 10 to the power plus 23. Okay, that means 10 to the power plus 23, you understand, right? You put 23 numbers of 0 after 1. So one side you have such a large number. At the same time I have another number which is too small, and both numbers are not easy to imagine. Okay. Now the question comes about your imagination power. Do you have imagination power to tell how small is 10 to the power 34? Can you imagine how big is 10 to the power 23? So these kinds of numbers goes beyond your imagination limits. But however, what is interesting is, we don't require our imagination limits. Instead, you simply close your eye and do the calculation. It works. So this is the surprise that is very important when we are talking about quantum physics. Because I said that it's going to be an historical introduction to quantum physics. And in quantum physics, we are going to see numbers like very small, like 10 to the power of minus 34, And in classical physics, we see numbers like 10 to the power plus 23. So both are very small and very big. So how do you compare which is big and which is small? I have written at the bottom. Avogadro number, that is 10 to the 23, is 57 orders of magnitude larger than Planck's constant. There are 2 points that are to be noted here. First point is, you have to take only 10 to the power number. Don't take what is there before that. 6.6, not interested, just forget about it. Similarly, 6.023, not important. When you are talking about order of magnitude, only 10 to the power is required. Anything else, you simply forget about it. It is not required. So, one side 34, another side is 23. You simply subtract that. So, 23 minus 34 is 57. 57 orders of magnitude difference is there. You have to feel the difference. This is very important. I am not showing some numbers to you. I am asking the children to get the feeling. Feeling is not easy to get. First you go to write, and you go and write an exam out of 100 marks, you get 1 mark. Okay? Your teacher is conducting an examination, you get 1 mark, 1 out of 100. Then everyone is saying that you are not doing well, do well, do well. Then what you do? You prepare next time. In the next exam, you go and score 10 marks out of 100. Got it? 10 out of 100. How much work did you do, or how much exercise you have done in order to get 10 out of 100? Okay, keep that. Then again, people are telling that 10 out of 100 is very bad. Again, you have to prepare well. What is the next number? 1 is over, 10 is over. Next number is 100. So you have to get 100 out of 100. How much work you have to exercise in order to get 100 in the next exam? Is it easy? So, point is clear. Moving by 1 order of magnitude. 1 going to 10 is difficult, 10 going to 100 is difficult, 100 going to 1000 is difficult. It is not that easy as you think. For example, if my salary is 1 lakh per month, if you assume like that, if my salary is 1 lakh per month, then people are saying your salary is very less. Then what is my next number? Next number is 10 lakhs. Can I increase my salary to 10 lakh per month? People struggle a lot, they can't increase. They struggle to increase by small number. 1 lakh will not increase to 10 lakh. And that amounts to enormous amount of work which one cannot imagine. This is the point I am trying to say. But nature operates like this. This is not the number that we created. Nature is operating numbers ranging from 10 to the power plus 23 to 10 to the power minus 34. That number range nature is operating means how powerful the nature is. That is the wonder, because you have to get some wonder, right? You must get some exclamation mark. If you don't wonder for anything, you will be keeping quiet all the time. So there should be some kind of surprising point in science. Only then you will be interested to look into what is going on. If you are not getting any interest, then nothing will happen to you. So the point of this particular event is, or the whole idea about the National Science Day program, is that the children should get some kind of interest by this topic or by some other topic. For any topic that you are going to choose, are you getting the interest to find out what is the reason for this? So that is the main purpose. So that is the second point. Now let us go to the next slide. Okay, so this is the same thing that I told you, that the 6.6 and 6.023 is not required for calculation. Then, so I have written some words here. Some of the English words you have to give carefully, see the word classical. Okay, there are 2 words which are going to come. One is classical, the next word will be quantum. So classical numbers will be very, very big. You see 10 to the power 21, 10 to the power 7 meters, like all are very big numbers. These are the size that we are having, that you can observe. The one which can be observed very easily is the last one, namely the grain of the sand. You go to the beach and take one sand particle, approximately it comes like 1 millimeter. That is what you can feel. The next number you can feel is football. You can feel how big a football is. You can measure and see whether it is matching to 0.1 meter or not. Okay. And other things we cannot directly go and measure and see, but these are the numbers it is. So we are having galaxies of the order of 10 to the power 21 meter. So it is that big. When you have large sized information like this, we use the word classical. So note the word classical here. And then when we go to the next slide, we are now having a word quantum, and all numbers are very small. You can see 10 to the power of minus 9 meter. The first number that I have written, 10 to the power minus 9 meter, is what is called a nanometer. So note that point, nanometer is the first one. Then everything else comes smaller than that. And electron is, we don't have exact number, but still it is less than 10 to the minus 18. Quark is going to be even smaller than that. So the numbers are 10 to the power of minus 18 meter or even less. So this is the point that you have. And here, if you see the topics that I have chosen, somehow I would like to make some kind of interest should be created to the students. Is the point clear? So for that reason, I have chosen some topics, okay, which will create some interest to the students. And then we will choose different topics and we move along. And here is the 1968 photograph taken by NASA. And people were interested in knowing how they have taken the photograph of the Earth, okay, from the moon. So this is the photograph taken from the moon, and then the photo is Earth itself. So it created a lot of interest, and then people were thinking that US is doing very nice or great. And so now the question is that rocket science is so difficult or so easy. The answer is, it is neither easy nor difficult unless you put your step further. Okay? If you are not interested to learn anything, there is nothing to ask this question at all. So whether it is easy or difficult depends on how much interested you are to learn that particular topic. Okay, so if you are interested, okay, let me know what is this rocket science. If you ask that and get interested and motivated, then the first step ahead is very simple. Yes, it is easy. Understanding the rocket science is easy because the first step is that you have to push the rocket upward, and for that you will be playing with this balloon. And once you tie the balloon like this, filled with air, and once you release the air in this blue color direction that I have shown, then everyone can easily understand that the balloon will be moving in the forward direction. So this is the starting point for a child to know that something is happening with equal and opposite. So some starting point is required, right? So the child has to capture some moment where it is interesting. Then the child will keep repeating the exercise with the various size of balloon. You have to do it. And only then you will recognize that it is powerful. And we say finally, what you want to say finally is that the so-called equal and opposite reaction pair, that is going to push the rocket upward. So the rocket science starts there, which means that the Newton's third law is the starting point to push it above. So there are certain words are there which are important. One is action, the other one is reaction. When we are talking about reaction, we are not saying anything about chemical reaction. So people get too much of confusion because morning 9 o'clock chemistry class will be there, then 10 o'clock physics class will be there. Just 5 minutes back chemistry teacher told about chemical reaction, and physics teacher will tell equal and opposite reaction. So child will get totally confused. No one is there to explain that reaction and this reaction are different. So it is the headache of the child to clarify what it is. Is the point clear? So the words are very important. Your English dictionary cannot provide the correct meaning. This is very important point. That is why we say it is terminology. Terminology is the meaning of a particular English word which is restricted to that particular subject only. You cannot copy the meaning of one subject to another subject. This is the place where most of the students are not clear about. So unless you know a particular meaning, only then you have to proceed further. And there is second one, the bottommost I have written, whether you say action or whether you say reaction, they all represent the force. Because in physics we need only units and dimension. We are not interested about the English word there. So whether you say action or reaction, it's all the force, therefore its dimension is Newton. Okay? So in which direction it is acting, you can attach a plus sign and minus sign. So that's a point to be noted. So whichever is important point, you try to remember what I am saying. So that's very important. And then the next slide goes, now since the earlier picture was at NASA, and the question is that how much India is also progressing in this direction. As our esteemed Vice Chancellor also mentioned, Chandrayaan is the one that India has launched and got a very good name for that. And the main purpose, why did we do that? It is there in the next slide. Yeah, some launch date, some history is there. It is the launch date, landing date, etc. is there. And then mainly it has reached the South Pole. And then what is the major achievement that we would like to do first of all? We want to do some research, all these things is later. But what is you see the last one? India is the first country to land near this South Polar region, that is okay. But then it is a fourth country to achieve the soft landing. That means India is a country which has achieved the soft landing. That is very important point. So achieving the soft landing is one of the important motivation for launching the rocket. Doing the scientific research is secondary. The rocket is going very fast. How fast it will go? Typically 11,000 km per second it will go. Okay, just imagine the numbers. 11,000. When you run fast, you can go only 1 meter per second. Okay, that's what you remember. 1 meter per second only you are running. But 11,000 km per second is the speed at which rocket typically travels. If it is going so fast, when the moon comes, how will you apply brake? You cannot apply brake. You are going in the sky. So the question is that it is not trivial. It is also not very clear how will you put your brake and how exactly will you land. If you go very fast, then you will be hitting the moon, and that is called hard landing. Hard landing means totally you are going to destroy it. Why to destroy our rocket on the moon? We can destroy on Earth itself. Isn't it? So the question is, why should you take it to the moon and destroy? So the point is that the very important objective of the Chandrayaan is not to do the research. Research you can do later. First of all, let us land properly. So that is the point that I have written. So we have to reduce 11,000 km per second to 1 meter per second. That is the speed you have to reduce. How to reduce controllably? You have to reduce properly, and that is the big achievement which India has done in this particular Chandrayaan. That is one of the achievements. Okay, once landing is done, they have done some research. The next slide shows this. What they have done is they have seen the composition of the soil and rocks, and then they detected some elements like sulfur for the first time, and they measured the temperature variations, and then they also measure, just like earthquake, you also have moonquake, and then you have the presence of some water ice, because water is very important for living, right? So that is why water is very important, and whether human can survive there, that is a potential question that is remaining. So these are additional research that one can do. Okay. Balloon as a starting point I told you. Then you see that you cannot do anything without some calculations. So what calculations are required in order to lift this rocket and then put it in an orbit? You see, this is the point that I have written, that you need the Newtonian mechanics, that is first law, second law, third law. You have to do some calculations. That means you need a calculus. In fact, calculus itself is discovered by Newton. Because when the Newton is discovering the first law or second law, calculus was not there. He himself discovered calculus. Then he said that the dv by dt is acceleration. So who discovered dv by dt means Newton himself discovered. So later it was expanded by other mathematicians like Leibniz. So the point is that Newton himself has done calculus, and then you have to do further calculations to computer. For that you need linear algebra. Then you can do numerical calculation. So all these things if you do together, then only you can think about real mission. Really, if you want to do something, you have to do a lot of work, which means that you need a lot of mathematics. Is that point clear? Newton's laws are okay, but Newton's laws only tells you 5 lines. 5 lines, if you tell Newton's laws are over. So how can you send the spacecraft? Means you have to perform a lot of calculations, and calculations require a lot of mathematics. That is what I am trying to say. And when you go to the next slide, here are some small equations. The purpose of the equation here is that you have variety of audience here. I do not know whether there may be some undergraduate students from some colleges also who are attending. So they can see at least some equations, minimum equations that you have, which are required in order to calculate what is the nature of the orbit and how fast one has to go, what are the conservation laws, etc. So you have the conservation of energy and the conservation of angular momentum. They are coming from the equation of the orbit itself. The first equation is not a simple equation. It looks simple, but it is not simple because it is a vector equation. It is not scalar. So if you go to the next slide, I will expand the vector equation. And here, vector equation is now decomposed into 2 scalar equations, and one for x and one for y. Now this is where the difficulty comes. Unless someone starts to solve this equation, you do not know what the difficulty is. Okay, unless you have to first take a paper and then try to write first line how to solve. Only then you recognize what is the difficulty. Until that, you do not know what is the difficulty. So let me now explain what is the difficulty. In the first equation you have d square x, right? So x is unknown quantity. That's what you understand. Anybody can understand, no need to know mathematics. When you have d square x is unknown quantity. Then you see the next term, you have bottom what you have, x square plus y square. So y also is there. If I don't know y, how can I calculate? So x is already unknown, that is there in the first equation, but there is another variable y. Y value also I don't know. Now you see the second equation. In the second equation you have d square y. D square y means y is unknown. So y is also unknown. First equation x unknown, second equation y unknown. Then how do you solve this problem? This is a coupled equation. So this is like this. There are two variables are there, x and y. In order to solve x, I need y value. Okay? So y is another person, x is me. You assume like that. X is me, y is you. If you give me your value for y, I can solve x. So I am asking you, please give me y value. Then how you are replying? You are saying that I can solve y, no problem, but first you tell me your x value. Is the point clear? So if you give me y, I can solve x. If I give x, then only you can solve y. So both the people will be fighting and standing. Nobody will solve it. The hydrogen comes into picture both for the as a propellant for the rocket and for the surviving on the earth. Both places it is very useful, and you can see this particular point is very important. What it is shown here is that the majority, namely the 62% of the energy is coming from fossil fuel. Fossil fuel means anything like petroleum fuel that you are going to use. Anything from the petroleum is the fossil fuel, and we are going to get depleted. That means it is reducing day by day, and we will not be having unlimited supply of the fossil fuel. One day will come, that is the end of the fossil fuel. If that happens, how are we going to survive? That is the question. The remaining numbers are small. Okay, so we need to replace the 62%. Who is going to replace 62% of the fossil fuel? That is the question. The answer is hydrogen. That is what I would like to say. The answer is hydrogen can replace everything. Not only 62, it can replace the entire 100. So hydrogen has that ability. The question is that from where it has the ability and why it is green. So this is the reason that I have written. I can go to the next slide. Here is the point. This will tell you that you don't require any kind of carbon based fuels. That means you don't require methanol, ethanol or petroleum. Nothing like that is required. You start from the sun, solar energy. Solar panel will give electricity, provide the electricity to the electrolysis setup. Electrolysis setup will have water, okay, and the water will be under electrolysis, water will convert it to hydrogen and oxygen. So this is something which school children are aware somewhat. Water can be converted to oxygen and hydrogen, and once it is converted, you collect them and then store them. So one of the storage that I have shown in pink color is hydrogen, and once you store that, you can give the same hydrogen to the fuel cell. Fuel cell will generate electricity, and if electricity comes, you know what to do. You can run the train or you can do whatever you want, which means that we don't want petroleum based fuels anymore. That's all about it. This concept is that this is the one which is going to be very useful, but there is one danger. I'll just say the danger and go to the next topic. Right now the hydrogen is available in this form of cylinder. Yeah, next one. You can skip this. Another, So here is the one. So you keep some kind of cylinder and then put it in the vehicle will run. That is the overall idea. And then you can go to further slides. This is the one as an example. You connect all the hydrogen cylinder, keep it on the top of the bus, and the bus will run, no problem, everything works very fine. But there is a big danger. So here I am showing some of the examples from the newspaper. That is some year maybe there, maybe next slide. Yes. 2010. So these are some examples from the newspaper where the accident has happened because of the hydrogen cylinder. 2011 is next one. 2018 from Indian Institute of Science. 2025. One more from 25. And 2026 once again. So till today, this month you have always some are the other accidents due to the hydrogen cylinder, and you cannot play with hydrogen just like that. Because hydrogen cylinder is there at 200 atmospheric pressure, we are living at 1 atmospheric pressure. So the cylinder is always dangerous that it will blast. It's an explosion. So explosion is dangerous. So the question is, how can we replace this cylinder? That is a question. Okay, so this is one research which is interesting, right? So I will just come out of that. What the light bulb said is, it doesn't just light the rooms. It's not only lighting the rooms, but they lead the path to the quantum theory. Okay, so the quantum theory itself got developed from this tungsten bulb. So that is the point that I would like to say. And how it has come, okay, that's a big story. So let us now, before going to the further details, let us see the next slide. Yeah. Since we are on this particular day, the C.V. Raman Day, right? National Science Day is C.V. Raman Day. So I thought this topic I don't want to skip. So I'll just mention an important point here regarding this scattering. There are two things that I would like to tell. What is Raman scattering? What is Raman effect? That is one question. But before that, I would like to tell that there is some misunderstanding, and people are also thinking wrongly what is Raman effect. Most of them, they will be thinking that blue sky is due to the relay scattering is the correct answer. But if you look at some of the YouTube videos, unfortunately, some people are explaining that the blue color of the sky is the discovery made by the Raman effect. Raman did not do that. So there is some confusion is there. So I would like to clearly tell that the blue sky explanation is not given by Raman. It's not Raman effect. It is originally the relay scattering. But what Raman did, we will see that next one. Here is the point. So you have the light which is coming. I am showing it by green color light. You can see, and it is hitting the molecule. As an example, I am taking water molecule H2O. So some 3 molecules are there, right? 2 hydrogen and 1 oxygen. So H2O is there. So the light comes and hits the green color light, let us say, as an example. Then same green light is emitted without change in frequency, right? Same green light is emitted means it is called relay scattering. Instead of green color, slightly, not a big change, but slight change in frequency happens. Another new light is emitted means it is the Raman scattering. So the distinction is very minute, so you have to be careful that Raman effect did not directly tell that same frequency light will come out. He did not tell that. It is anyway it will come out, but that is called the relay scattering. What Raman observed is the emission of a different frequency. That means a small change in frequency is there, and that is the discovery which is made by Raman. So because of that, what happens is consequence is there. This is one thing. While explaining this story, there is another point coming to picture, namely why sea looks blue. Then what happens is, relay said that sky is reflected, that is why sea looks blue. That was the answer given. Then Raman clarified that no, that is not the answer. The correct answer is light is falling on the water molecules of the ocean. Then ocean is reflecting the relay scattering. Is this point clear? So ocean is reflecting the relay scattering. That is why it is looking blue. So the sky is not responsible for that. So this answer is there. These two answers are somehow wrongly interpreted in many of the YouTube videos. So where children may be seeing that video and thinking that is correct. So I would like to clarify this point that what is written here. But elastic, inelastic, I will not go into the detail now. So now that the time is, we are running short of time. So I would like to at least mention one point about the quantum. Otherwise the title was history about the quantum physics. So I would like to tell this important point that in quantum physics what happens is that we have the so-called wave function to describe particles or wave. So that there was a big debate whether it is a particle or it was a wave. Okay, that debate has came to a conclusion somewhat around 1929. Okay, so there is no big debate after that. People agreed that it is simultaneously behaving like wave and particle. But then the different problem was there, which was observed, and then the experiment is known as the Schrödinger's cat experiment. The cat experiment, I will not go into detail what it is, but final conclusion, what it means is, according to quantum mechanics, the cat can be simultaneously, we do not know whether the cat is living or cat is dead. So you have two versions, right? one is the cat alive, the other one is dead. Both are there. So what quantum mechanics says is that only if you measure or only if you detect whether it is alive or not, you can find out whether it is alive or dead. Until that, we do not know. So when we say we do not know, quantum mechanics says is that it is some kind of combination of dead cat and alive cat. So this is the statement of the quantum physics, which started the difficulty of what is meant by a measurement problem. So this is the measurement problem means if only when you measure, then you will be knowing the result, namely that the wave function will collapse. Until that, there will be a wave function. So this problem was the Schrodinger's cat experiment. Yeah. The next one, this is the statement I told you. If you are unable to think how can it be simultaneously wave or particle, how it can be simultaneous means it is up to our imagination power. You have to think that it is simultaneously lion as well as a human being. How it is possible, that's not the question. The question is nature behaves like that. So that is the bottom one I have written as an equation that we traditionally write in quantum mechanics. Yeah, the next one. Yeah, next slide. Yeah, this is little. So the question comes like about realism. Okay, so this is what the question, quantum mechanics EPR paradox is all about, is to know what is meant by reality. So the next slide. This is little carefully you have to understand. This paper is written by Albert Einstein. So Albert Einstein has given this statement on physical reality. People get different difficulties in understanding, and sometimes they give wrong interpretation. There is a word called physical reality. So reality, according to Albert Einstein, is not talking about real object or imaginary object. We are not discussing something which is non-existing. We are not discussing something that you have to imagine. Einstein did not say like that. Reality, according to Einstein, in this particular paper, means that material or whatever material that you have, they have definite properties whether you measure it or not. That is called reality. Reality means this is an object that you have. See, for example, if this is an object, this object will have some properties, right? This object will have a property whether you measure it or not. That is called reality, according to Albert Einstein. And according to the Schrodinger's cat experiment, what it says is, only if you measure, you know the property. If you don't measure, property is not known. So that looks fairly complicated, how to understand that. That is why it is called a paradox. So EPR paradox, E means at Einstein. EPR means first author is Einstein, so it's called EPR paradox. Now this has, let me conclude this now, that this paradox started in 1935. Then it has moved to 1964, and then we will come to conclusion. Yeah, 1964, there is a big discovery called Bell inequality. Yes. Next, how to solve the EPR paradox Bell has given. Then after 1964, so and then this tells you that the problem started in 1935, came to an end in 2022. Okay, where the people have really performed some serious experiments, and they made a clear conclusion about the Bell inequality, whether Einstein is right or wrong. So it was quite a serious discussion. The conclusion is that Albert Einstein's decision written in that paper is wrong. So that was the decision in 2022. That was it was not easy to accept by many people, but however it has taken so many years until 2022, and the Nobel Prize was awarded for the three people who have proved that the statement that what Einstein claims happens to be wrong, in continuation with the path in 1964 Bell inequality. So that was a very big achievement. That in fact you have to remember one thing, that Albert Einstein has given the photoelectric effect E equal to h nu. He himself given the equation for the quantum idea, right? So then his own statement that in the EPR paradox apparently is not correct is the today's proof that we have as on 2022. So the conclusion is that this is a big way, and this conclusion has given people that people now can easily do experiment with what you call the entangled photons. People have done considerably good experiments with entangled photons, all because of this EPR paradox. And that has given development to the quantum computers. So I would like to conclude here, because quantum computers and the AI is the talk of the day, isn't it? So The quantum computer is there only at millikelvin temperature, so you don't imagine that it will come to the market so easily. Millikelvin temperature is something that you cannot achieve just easily, so it will be there in research lab for recent years. But however, people are doing the calculation at that temperature. That is the point to be noted. So unless students get some idea into the quantum world, only then you can proceed further. Okay, so with that kind of remark, I will stop here and expecting that somewhere in these topics people should have got some engagement. And thank you.
So before we proceed to the next segment, we would like to present a brief report of the events that took place over the last few hours, and also we would like to showcase a glimpse of the display screen for our audience members. May we please request Dr. Sangamitra, Assistant Professor, Food Science and Technology Department, to come to the dais.
It's my proud privilege to deliver the report on the occasion of National Science Day conducted at Pondicherry University. Under the visionary leadership of our esteemed Vice Chancellor, the National Science Day celebration were successfully conducted from 23rd February to 24th, followed by the Open Day on 25th. The event witnessed remarkable participation from both school and college students. A total of 61 schools from around Pondicherry and 28 colleges are actively participated in the celebrations. The school events recorded a total participation of 615 students, and the working model competition includes 69 teams who developed innovative models aligned with the theme of National Science Day. The essay writing competition witnessed the participation of 160 students, while the painting competition had 215 participants. And the theme across these competitions broadly focused on scientific innovations, environmental sustainability, green energy, women in science, future technology, and the role of science in improving human health and protecting the planet. The elocution and quiz competition had around 70 participants, which was coordinated by the Bioinformatics Department. The college and university events recorded a total participation of 233 students, including UG, PG, and PhD scholars. And the poster presentation featured around 19 teams, and the debate competition included around 50 participants, and the quiz competition had 48 teams. And the Department of Microbiology coordinated in conducting a national level agar art and painting competition inclusive of UG, PG, and PhD students. Around 31 universities and colleges across India participated, and comprising of 350 students. Altogether, 1,500 students actively participated in various competitions, making this celebration a grand success. To conclude the Science Day celebration, the Open Day at Pondicherry University was organized across various science departments where innovative exhibits and working models were displayed. Departments including physics, maths, biotechnology, bioinformatics, earth science, food science and technology, chemistry, biochemistry, microbiology, ecology, computer science, electronics engineering, library science, and SIF showed various models and demonstrations. The Open Day provided students and visitors with valuable exposure to research activities and technological advancements within the university. We are deeply honored by the presence of our respected faculty members, dedicated volunteers, and enthusiastic participants. Thank you.
So we now proceed the most awaited segment of today's event, the prize distribution ceremony, honoring the brilliant minds whose dedication and hard work exemplify scientific excellence.